viewers, till now I have discussed different techniques by which data can be collected from the ground. Remember, all these data have been finally stored in digital form within a computer. Now, these informations will be integrated so that digital maps can be generated. Advantage of a digital map is that it can be updated as needed and can be carried anywhere. So, in this session I will introduce the concept of GIS, that is Geographical Information Systems. The collection of data about spatial distribution of significant properties of the earth's surface in the form of maps by navigators, geographers and surveyors has long been an important part of activities of the organized society. Topographical maps can be regarded as general purpose maps, while thematic maps for assessment and understanding of natural resources are of specific needs. The use of aerial photography and remote sensing has made it possible to map large areas with greater accuracy for producing thematic maps of large areas for resource exploitation and management. Handling of large volume of data for quantitative spatial variation of data requires appropriate tools to process these spatial data using statistical methods and time series analysis. Introduction of computer assisted cartography. Many new tools were developed to perform spatial analysis of the data to produce maps in desired formats. These operations require a powerful set of tools for collecting, storing, retrieving, transforming and displaying spatial data from the real world for a particular set of purposes. This set of tools constitutes a geographic information system, or in short GIS. A GIS is an information system that is designed to work with data referenced by spatial or geographic coordinates. So, in a way, if we look at the illustration given below, GIS can be considered to be a data collection tool. It can also be considered as a data storage tool. It can also be considered as a data manipulation tool. As and when changes take place, we are probably able to undertake various stages of data creation and storing these data. Having done the manipulation and analysis of the data, we will naturally like to have some form of output. Now, these outputs could be based on the user action, that is what the user would like to do, or based on the user needs, that is whether he would like it in the form of a table, whether he would like to have it in the form of a graph, or whether he would like to have in the purpose of map. Because the task is that the user needs to use this information, and probably for planning stages this sort of system is a very ideal one. Once we do any activity with this new data set that has been created with the help of GIS, we can subsequently go back to the data collection, update the new information which may have been now derived, which means that this particular cycle is a never ending cycle. Every time the data changes, the cycle gets initiated, and at the end of the whole exercise a new set of information is available which again needs to be stored. So, this would never, it would be a never ending and a continuous process in the real sense. Having provided the basis or the background of the information collection and its subsequent use in GIS, let us look at the definition of GIS. A geographic information system should be thought of as being much more than the means of coding, storing and retrieving the data about the aspect of the earth's surface, because these data can be accessed, transformed and manipulated interactively for studying environmental processes, analyzing the results of trends or anticipating the possible results of planning decisions. Geographical information system is associated with few basic terms such as geography and information system. The literal interpretation of geography is writing about the earth. In writing about the earth, geographers deal with the spatial relationship of land with man. A key tool in studying the spatial relationships is the map, which is a graphical portrayal of spatial relationships and phenomena over a small segment of the earth or the entire earth. On the other hand, an information system is a chain of operations that consists from planning the observation to using the observation derived information in some decision making process. Thus, a GIS is both a database system with specific capabilities for spatial reference data as well as set of operations for working with the data. Some of the definitions of GIS given in different publications are: a GIS is a system which uses a spatial database to provide answers to queries of a geographical nature. A computer assisted system for the capture, storage, retrieval, analysis and display of spatial data within a particular organization. Another definition is a powerful set of tools for collecting, storing, retrieving at will and displaying spatial data from the real world. Another definition could be an organized collection of computer hardware, software, geographical data and personnel designed to efficiently capture, store, update, manipulate, analyze and display all forms of geographically referenced information. Well, this information has been given by ESRI, one of the lead software based companies presently in the market of GIS. So, if we look at the last definition which has been given above, it is one of the most rigorous definitions of GIS. This definition includes requirements of personnel trained in the technology who can capture, store and update the data and provide answers to the complex queries of the management by integrating information contained in various layers through maps, tables and charts. Further, GIS is also the result of linking parallel developments in many separate spatial data processing, as it can be seen in the figure below. That is to say that the development of GIS has been brought about with the development in various ancillary and associated technologies such as computer aided design and computer graphics, surveying and photogrammetry, spatial analysis using rasterized data from thematic maps, interpolation from point data, remote sensing technology, cartography, that is the science of high quality drafting. All these combined together have provided the necessary impetus to this GIS technology to take charge of the information crunching and providing the desired level of data in and information in different forms. So, with this, let us look at what are the components of a GIS. The components of a GIS can be defined in different ways, but very comprehensively it can have the following components. First, a computer system having hardware and operating systems. Second is a software. Third is spatial data. Fourth is data management and analysis procedures, and fifth, personnel to operate the GIS. So, let us look at each of these components one by one and also the role that they have to play. The hardware components of a GIS comprise of a central processing unit, that is a CPU, a disk drive, a tape drive, a digitizer, plotter and visual display unit. The disk drive and tape drives are basically data storage devices. The tape can be used for communicating with other systems. This particular figure shows the various major hardware components of a GIS. As emphasized, the CPU is the main heart of the computer, which links to a video display device on which all the informations are displayed as commands are executed at this computer level. Well, the input to certain activities would be carried out by the keyboard, and in case of interactive softwares, the mouse may be used to provide inputs to initiate actions. The data input could to the GIS could be through a digitizer, wherein a hard copy map may be converted into soft copy by virtually acquiring and capturing data with the help of a mouse and a digitizer, so that all the information present in a graphic or in a map is converted into certain x, y and its corresponding attribute. This attribute could be height, it could be any other information, maybe the length of the road or the width of the road, or it could be the type of feature, that is water bodies, or it could be a forest. The same task could be done by having a scanner, wherein the hard copy maps or graphics could be scanned by the scanner and converted into a soft copy, which would be then subjected to a process of digitization, which would be on screen displayed on the VDU to the user, who would then with the help of the mouse would convert the information into plausible form. The GIS naturally will have lot of outputs which would be coming. These could be in the form of texts, tables and maps. So, one may need a printer to print the textual informations, the tables, and may require a plotter for printing the maps. Having done this, the whole information need to be safely stored somewhere. So, there could be disk drives in which the data could be stored, or there could be tape drives wherein bulk data storage can be carried out. The next component is the software. The GIS software package has the following set of modules for performing the various tasks. These tasks could be digitization, editing, overlaying, networking, vectorizing, data conversion, analysis for answering the queries and generating outputs. The next is the input data, that is the spatial data. This is the heart of GIS, wherein it would be performing all different types of analysis to provide interesting information. So, spatial data are characterized by information about the position, connections with other features and details of non-spatial characteristics. A GIS software is designed to handle all spatial data. Spatial data require spatial referencing using a suitable geographic referencing system, which should be flexible and lasting, since a GIS may be intended to last many years. A traditional method of presenting the geographic space occupied by spatial data in a GIS environment is in the form of a series of thematic layers. The spatial data layers represented as either layers of objects are simplified by breaking down all the geographic features with three basic entities types such as line, points, lines and areas before they can be stored in the computer. Well, this slide shows the transformation of the real ground into information layers depending upon the type of information. If we see at the lower at most, we have the block of the earth surface, and on this earth surface there are different types of informations pertaining to road, type of buildings which are there, the type of agriculture, the trees, all different types of information as they are integrated and lying, and they have a certain amount of interrelationship amongst them. But when we want to analyze or make analysis of information, probably we need to segregate all this information into different layers, and what you find is we can convert the ground into different layers consisting of information related to the road network or to the type of housing schemes which are there, or the type of tree structures as they are located, and thus in a way all these informations are now being split and made into specific layers of information. So, in a nutshell, we can say GIS allows us the information segregation into desired information categories. Next component of a GIS is data management and analysis. Input data in the form of spatial data and non-spatial data and the information about their linkages and updating of data are the most expensive and time consuming part of any GIS project. Data input is the process of converting data from its existing form to one that can be used by the GIS. The management of data in GIS includes storage, organization and retrieval using a database management system, that is DBMS. The DBMS should support for multiple users and multiple databases, allowing efficient updating and minimizing the redundant information. It should also allow data dependency, security and integration. GIS analysis procedures include A. Storage and retrieval capabilities for presenting the required information. B. queries allowing the user to look at patterns in the data. C. Prediction or modeling capabilities to have information about what data might be at different time and place. The data output in GIS depends on cost constraints, the type of users and the output devices available. The next component is the personal operating GIS. A GIS project requires trained personnel who can plan, implement and operate the system. They should also be capable of making decisions on the basis of the output. The success of any GIS project depends upon the skill and the training of the personnel handling the project. Having discussed the components of a GIS, let us look at the geographical concepts on the basis of which GIS is built. The geographic features on the earth can be represented by three basic entities types, that is points, lines and areas. A spatial object represents a geographical area having a number of different kinds of associated attributes or characteristics. A spatial object with no area is a point that can be associated with a range of data such as wells, rain gauge stations, etc. One of the key attributes of a point is its geographical location represented in terms of coordinates such as latitude and longitude. When a spatial object is made up of a connected sequence of points, it is referred to as a line. Lines have only linear dimension, that is, they do not have any width, and a specified location is given on one end of the line and not on the line itself. Attributes to a line could be the number of wells that the line separates in an area having wells. Nodes are defined as special kinds of points that usually indicate the junction between lines or the ends of line segments. A closed area is represented by a polygon. A polygon can be simple when it consists of undivided areas or complex when it is divided into areas of different characteristics. Chains are special kinds of line segments which correspond to a portion of the bounding edge of a polygon. In the context of spatial objects, the concepts of scale and resolution must also be clearly understood. Scale is the ratio of distances represented on a map or photograph to their true distances on the earth's surface. A scale of 1:50,000 indicates that 1 unit distance on the map is equal to 50,000 units in the same units on the ground. A map may be small scale map or it could be a large scale map. Resolution is an important concept when dealing with spatial data. Its literal meaning is distinguishing the individual parts of an object or the degree to which detail is visible on a photograph or on a television. In case of spatial data, the more specific definition is the content of the geometric domain divided by the number of observations normalized by the spatial dimension. So, the mean resolution element can be defined as the square of the area divided by the number of observations. Smaller is the mean resolution element, higher is the resolution of the data set. Now, let us look at what are the input data requirement for GIS. Input data for GIS cover all aspects of capturing spatial data and the attribute data. The sources of spatial data are existing maps, aerial photographs, satellite data, field observation and other sources from which the data can be collected. The spatial data which is not in digital form are converted into standard digital form using digitizer or scanner for use in GIS. This particular slide shows the various sources from where the data can be collected. These could be from maps, aerial photograph, satellite imagery, field observation and other sources. The digital data as shown here will then be the integral part of GIS analysis procedures. Having had a look at the various type of input data, because these we have discussed previously elsewhere in detail regarding how the information can be acquired, analyzed and then sent. So, no detailed discussion is being carried out at this point. Once we have the input data, naturally after certain processes have been performed, this data will naturally have some result. So, let us look at the type of output products that one can have. These could be thematic maps, choropleth maps, proximal or dismetric maps, contour maps, dot maps, line maps, landform maps, animated maps and non-map graphics. So, let us look at thematic maps. It concentrate on spatial variations of a single phenomena. For example, it could be population or the relationship between phenomena, that is different classes of land cover. Choropleth maps are typically used to communicate the relative magnitudes of the continuous variables as they occur within the boundaries of the unit areas, that is average annual per capita income as it varies by country. In these maps, different tones, colors and shading patterns are used to convey the variation in different areas. Proximal or dismetric maps focus on the location and magnitude of areas exhibiting relative uniformity, that is land cover classes. Different colors and shading patterns are used to describe differences in the thematic values. Contour maps represent quantities by lines of equal values to emphasize gradients among the values. Contour lines may be used to indicate variation in topography or in a region of high or low pressure. There can be different types of informations which could be present by these. A dot map depicts spatial distribution of features by varying number of uniform dots, that is population. Line maps show the direction and the magnitude of potential or actual flow, that is to show the sources and the destinations as well as the volume of product transported from one state to another state. Landform maps depict the earth surface as they were viewed from an oblique aerial viewpoint. Animated maps are generally used to display sequences through time, that is growth of a city as its population and area increase through time. Some analysts or users prefer to get the result of the analysis displayed by means of non-map graphics. Some of the simple and common graphic representation techniques are bar charts, pie charts, scatter plots, histogram. Bar charts are used to illustrate differences in a attribute between categories, that is time varying distribution of land use in an area such as urban, suburban and rural. Pie charts for displaying information by dividing a circle into sectors representing proportions of the whole, that is in a state percentage of rural, suburban and urban population. Scatter plots are used for displaying behavior of one attribute versus another attribute, for example, yield and applied fertilizer. Histograms are used to show the distribution of a single attribute to examine the way the attribute is apportioned amongst the different possible values, that is percentage of education at primary, secondary, higher and other levels. Having had the look at the different types of outputs which are possible, the next is application areas. GIS finds its application in all those areas where professionals are involved in management and planning, utilizing analysis of large amount of geographical data that relates to space, typically involving positional data. Positional data determines where things are or perhaps where they were or will be. In other words, it is dealing with questions related to geographic space. Some of the typical applications may be as under. A forest manager may want to optimize the production of timber using data on soil and current tree stand distribution under a number of operational constraints. A geologist may be interested in identifying the best dam site by analyzing the earthquake data of the area and rock formation characteristics. A geoinformatic engineer may want to determine the best sites for his company's relay stations, taking into account the land prices and topography, etc. GIS is used to study the phenomena which are man-made or natural. Urban planning essentially requires a thorough understanding of the interrelationships between various entities such as road connectivity, schools, hospitals, police stations, etc., with respect to human settlements. On the other hand, in geomorphology, ecology and soil studies, natural phenomena such as rock formation, plate tectonics, distribution of soils are analyzed. GIS applications also consist of study of both natural as well as man-made entities together. The effect of human activity on the environment is referred to as environmental impact assessment, involving the analysis of data, both natural and man-made features. A study on the growing industrial units in an area is a problem of environmental impact assessment. GIS has distinct applications in feasibility studies such as site suitability and simulation studies in erosion modeling. Well, here I have just presented some of the very common application areas. However, the list is long. With this, I now conclude this particular session, and in my next session, I would discuss the various types of data, that GIS data and their various characteristics or we shall be using the word attribute from now rather than the word characteristic, because in GIS attribute is a very important terminology. Thank you.